So I'm Oliver. Just a quick background about me. I've been a software engineer for way too long, 20 some odd years, maybe more. I'm currently a co-founder, there's four of us, of a company called Companion Professional, and I'm going to talk a lot about that going on. And I should say, by the way, if you have any questions, please interrupt. I'd much rather be interrupted than lose the audience, and that actually helps me know that people are listening. So raise your hand or just start speaking out. That'd be great. So I'm going to start by talking about the problem of arthritis in dogs and how hard it is to diagnose and why it's a big issue. And then I'm going to talk about a big trial our company just did with a very large pharmaceutical company to demonstrate that we can detect arthritis in dogs very early with machine learning, earlier than clinicians usually can. And then talk about kind of how we're planning to take this to market and that kind of thing. So, for those who don't know, arthritis is joint swelling and tenderness. There's lots of causes. Osteoarthritis is probably the most common, both in dogs and in humans. And that's just basically wear and tear. It's like, you wore out the shocks on the car. So the cartilage wears down, and it starts with the cartilage wears down, it gets painful, and then as you can see, you get bone changes and things as well. There are other causes like rheumatoid arthritis, which is an autoimmune disease. But for the purposes of this talk, we're mostly focused on osteoarthritis. Really what our algorithm does is just detect pain. We're noticing gait abnormalities in dogs when they're walking around. But the trial we did was with a pharmaceutical company who has a drug for osteoarthritis, and so that's the focus of this. So that's my little arthritic monster there. That's Gordy. So it's hard to know how many dogs have arthritis and it doesn't go diagnosed. There are very little published research on this. So if you talk to pharma companies, and I've talked to a bunch, they've all done internal research where they do things like recruit a whole bunch of dogs and then just assess them. And the estimates you get for how many dogs will get arthritis at some point in their life is anywhere from like 50% to 70%. It's incredibly prevalent. There is new research. This guy's actually on our board of directors. Duncan LaSalle is one of the leading thought leaders in arthritis in dogs. He teaches at University of North Carolina. He just did a study where they recruited a bunch of dogs under 4. So just randomly selected, I forgot how many, several hundred dogs are under 4 years old, over 8 months. And 25% of them had arthritis. It's huge. Of the ones who had arthritis, 70% of their owners were not aware. And only 12% were getting any kind of treatment. And there's a lot of things you can do that's preventative and so on, so catching it early is really helpful. The median age of diagnosis for dogs is 10.5 years. So if 25% of dogs under 4 have it, and most dogs aren't getting diagnosed till they're 10, you're missing a lot of stuff really early, and that can really impact your ability to treat it and the longevity, the lifespan of your dog. So, a bunch of things you can do, right? If you know your dog has arthritis, particularly early stage where the signs aren't really evident, you can do things like lose weight. That's a huge one. Another really big one is just change how you play with your dog. Instead of throwing the ball on the pavement or on hard ground, take him swimming, right? You can do stuff like that that really slows the progression. And there's drugs, and in particular, there's some new, very effective, but also very expensive drugs, which is why the pharmaceutical companies are excited about what we're doing, right? So this is hopefully a virtuous cycle where we can get some dogs some help, but also the pharmaceutical companies are very happy because they get to sell more medications. You don't start with the big guns there, by the way, the drugs. You start with take some weight off and take your dog swimming and stuff like that. But if you catch it early, by the time you're 10, they're probably going to need something. So why is arthritis missed? It's really hard to detect. And I thought I would show you a video of a dog with known arthritis. And as you can see, I'm not going to turn the volume on because it's not worth it. There's annoying talking over the top. But this is a video showing a dog with fairly severe arthritis. And this was a video to teach clinicians how to recognize arthritis in dogs. And the voiceover is like, as you can clearly see, this dog has a limp. And I'm going to play the video, and I think most of you are going to be not so clear. Did anyone see it? Would you have seen it if I hadn't told you to look at it and it didn't say in big letters? And that's a pretty advanced case, right? That's not the 4-year-old dog who has arthritis. That's a dog who's probably getting treatment. So it gets missed for a bunch of reasons. One, dogs can't talk, that's obvious, well, except for Scooby-Doo. They don't behave normally in the vet clinic, right? You take your dog into the clinic and either they're really scared and they won't walk around at all, or like mine, they're super excited. Someone's giving them treats and they're like bounding around even though they're in pain because they're all kinds of happy. And like we've all had pain before, and if you're happy enough and the things are exciting enough, you sort of ignore it, right? You can do x-rays, but x-rays alone are not diagnostic, which is kind of interesting. You can have two dogs that both have arthritis on x-rays, and one appears to feel fine, shows no outward signs of pain, happy to jump in and out of the car, happy to run. Another dog with the same looking x-ray is in a ton of pain. So if you can determine that the dog is in pain, the x-ray helps you figure out the source of the pain. Like, is it arthritis? Is it a broken bone? Is it, growth on the bone or something? But just an x-ray alone won't tell you. And of course, to x-ray a dog, you often have to sedate them. So that's kind of big guns, right? So if you bring your dog into your vet, they're not going to screen your dog for arthritis unless you ask them to, because it's very hard for them to do. And it also involves some things the dog doesn't like. You kind of grab their legs and you yank them around and stuff and see if your dog seems uncomfortable. So if the owner doesn't know and doesn't ask for it, and the vet doesn't suspect it, it never gets screened for. And even if it does get screened for, it's pretty hard to detect. So that's kind of the root cause of why so few were detected. Oops, that was the wrong title slide, that's right. Reminder, please do interrupt if you have questions. So what I'm going to describe, we partnered with a large pharmaceutical company, and they recruited a whole bunch of dogs. So 137 dogs in the training set, 44 dogs in the test set. I'll explain that terminology in just a second. They took these dogs, and they were recruited sort of randomly, right? They went to a bunch of vet clinics and asked the vets if they would participate, paid them money if they were willing to. And these were like general practitioners, so all kinds of dogs were coming in. And when a dog would come in, they would say, hey, if you're willing to let us use your dog in this study, we'll give you stuff. Some money, free drugs, all kinds of stuff. And then they would do a full workup on the dog. So there's an assessment called the COAST assessment. It's kind of a framework for how you assess for arthritis. It includes a physical exam of the dog. It includes a questionnaire for the owner, like is your dog still jumping up on the couch and things like that. And it includes x-rays. So they do this whole big workup. And then they walk the dog around in front of our camera rig. So very inexpensive camera, much less good than what's on your phone. They walked him back and forth in front of this camera a few times, and they gave us the videos. And then for the 137 dogs in the training set, we got the videos and the ground truth labels, the vet's assessment of whether this dog had arthritis or not and how severe it was. And then the pharma company, because we were trying to prove to them we could do this, there were 44 dogs where they gave us the videos but not the labels. So we were not told what the diagnosis was. And our challenge was do a bunch of machine learning on the 137 dogs and then apply that to the remaining 44 and assess our performance, right? So after we had run it all, we sent to the pharma company what our results were. They unmasked it all, and then we did a bunch of statistics to see if we're accurate or not. Does that make sense?
Mm-hmm. Was that on the test set or on the training set?
So we train on the training set,
Yeah.
and then the assessment of our accuracy is on just the test set.
So the training set had labels?
Training set had labels, yes. So the way this works, roughly speaking, I'm not going to go deep into the technical details of this, but it's a deep neural network. So you take some video clips, you push it through this network, the network makes an assessment. I think this dog has OA or not, or it's severe or not. You look at the label, and then you say, hey, learn from that. You got it wrong. You said he didn't have OA and you did, or you said it was mild and it's severe. And you do that over and over and over. These training runs, a single training run is 72 hours on like the biggest GPU you can get. So it's a lot of compute. There's also 2 videos of each dog, it's probably not too relevant. And then, for comparison, there were 4 vets who hadn't done the assessment. So they didn't do the physical exam of the dog, they didn't take x-rays, they were just showing the videos. So they're doing the same task our ML is doing, right? They get to see the video, not the labels, not the physical exam, not the x-ray, and then they have to do an assessment based just on the video, and then we can assess, are we as good as clinicians or worse? And of the vets who did the video watching, 2 were general practitioners, and 2 were OA specialists. Sorry, OA is short for osteoarthritis. So 2 were specialists who spent all day doing nothing but arthritis. Yeah.
Is it hard to train on something that has a subjective element like this? Like, are you worried that if the 137 wasn't chosen well, that could make it difficult for you to develop a good model?
Yes and no. So most machine learning problems, there's, quote, noise in the data. And it should average out. It's actually not uncommon for a machine learning algorithm to learn to do better than people. So you can imagine if 3 people in this room saw the same exact dog, 1 person got the diagnosis wrong, and 2 people got it right, the machine learning algorithms can try to beat the average, basically, right? So they're going to end up learning somewhere between the 3 diagnoses and come out okay. But data quality is definitely an issue, and I should, for transparency's sake, we did stack the deck a little bit in our favor here, so we only recruited short-haired dogs and kind of mid-size. I forgot the cutoffs, but it was like above 15 pounds and under 80. So, and the small dog thing is particularly relevant. Small dogs tend to have a thing called a luxating patella. So have you ever seen a little small dog, it runs and then it does like a hop? Yeah, it's like its kneecap is kind of popped out for a second. It's very common. Yeah. I mean, and this is a tiny data set, right? For deep learning kind of stuff that we're doing, you're typically doing tens of thousands and millions of examples. We have only 137. In a lot of ways, it's bigger than it seems because we have several minutes of video, so we can grab different sections of video. And there's 2 videos of each dog, but still, this is a very small data set. So
why is it so small?
It costs a ton of money. Right? You got to get a vet to do a full exam. You pay the vet, you pay the owner, proof of concept. So since it was such a small set, we thought like let's at least reduce the diversity here, so we don't have to learn what arthritis looks like, and an Irish wolfhound is super fuzzy and giant and walks differently. So still a pretty big range of dogs. I would guess the size range we're talking about and the constraints still covers about 80% of dogs in the country. But one of our next steps is to, and I'm going to talk about this at the end and even do a little demo, is to really expand the size of our data set. And so we've got a whole thing we've built out to recruit vets, and hopefully by the end of the year we'll have thousands of videos. Yep.
Does it get any other information besides the videos?
Nope, it gets the video and the diagnosis, and that's it. Mm-hmm.
So, like in statistics, you should do statistics with less than 20 samples. Is this like kind of that rule of thumb that you went to that 137?
Oh, like how do we pick that number?
Yeah. Is there like a minimum, kind of like don't do AI with lower than this training set?
Yeah, I mean, there's lots of tricks you can do. So I don't want to get too deep into this, but you can do things like you can start with pre-trained models. So it turns out if you train a machine learning model to do one task, let's say train a machine learning model to say, is this a cat or a dog? You give it a picture, cat or dog. It has learned a whole bunch of stuff that's really quite general on the way to that. So deep nets, they're called deep because there are many, many layers. So the first layer is learning things like, is this a diagonal line or a horizontal line? Is this a vertical line or shading? The next layer is learning to combine those things. So if there's a vertical line and a horizontal line, it looks like maybe a square, or maybe it's starting to look like an eyeball, right? The next layer is learning similar stuff. And so as you go through that network, you get richer and richer information. And the very task-specific stuff, the like, is this a cat or a dog? That only happens in the last few layers. So one of the big tricks you do is you take a model that's been trained on an open data set, like say ImageNet, which is millions and millions of images. You take that model, you chop off like the last 4 layers where it got real specific, and you use the top layers, and then you add some stuff on top of that. So that model has learned to be very, very general, right? It's learned what comes out of that is like, I saw a leg, not I saw a brown smudge with a white spot, right? So it's already kind of generalizing stuff, and then you can build on that. And so depending on the complexity of your task, you can often in deep learning get by with surprisingly small data sets if the transfer learning is good enough, if you can find a pre-trained model on a relevant enough task. This is a very big model with a couple pre-trained models and a bunch of stuff on top of that, and we're kind of treating it as a trade secret, so I'm not going to give you all details, but that's a big part of why you can get away with just 137 dogs, is there's already stuff that has learned a big part of the task that you can just reuse, and that really helps you. And then, the 44 was picked, like, you can do a statistical analysis, what's the power of the test? If I'm going to give you a 95% confidence interval, how many examples would I need if I'm hoping my target rate is whatever? So we didn't just pick it out of the hat, but certainly we wanted more dogs, but they had a limited budget.
So for example, that pre-trained model might already know this is a dog walking. Is that kind of like where you might get your baseline from?
So the pre-trained models that are available, there's very few available on video.
Okay.
Video is harder. But you can take pre-trained models that are trained on images. So ImageNet is a great example, as is Coco. So these are big, freely available data sets. There's like open competitions. They have like 5,000 categories. So it's cat or dog, but it's not just dog, it's breed of dog. So it's an image classification task. You show it a single frame, and it's supposed to tell you this is a dog, or this is a golden retriever, or this is a starfish, or this is a human. So it's learning lots of stuff. And what's interesting is in those kind of layers before the end, all of that information is represented as a single string of numbers, a single vector of numbers, fairly small, like 1,000 numbers or so, 1024 usually. And in that small set of numbers, there's enough information that later on you can distinguish a kite from a starfish, from a dog, from a golden retriever. So that's called an embedding, and you do stuff with those embeddings. Cool. Make sense?
Yep.
Cool. Okay. So, mentioned there's 2 videos. Videos vary tremendously in length, between 2 and 15 minutes, to do what we'd asked them to do, which is walk the dog back and forth. And they also had like a jazzercise platform, like if you were right with the dog would have to walk up and back down, and then they'd ask them to sit. Some vets got right to it. They walked the dog, no problem. They're done. It's like a 2-minute video. Some, they turn the camera on and then they start chatting, and then the dog walks in the frame but gets scared, and so they take the dog out and they feed it treats. And so, huge disparity in how long they were. And this is particularly challenging. If you know anything about deep learning, you can't take 15 minutes worth of video frames and pump that through a model. At least, you'd need 100 GPUs for a single pass, right? It's a ton of data. But we don't know, all we know is the diagnosis of the dog, right? We don't know which limb it is. We don't know if the dog has arthritis. We don't know if the dog is in the frame, right? We just got all these frames. And so one of the really big challenges in this is, how are you going to take a bunch of footage where maybe the dog's moving, but it's the right elbow that's affected, and right now the dog's left side is facing the camera? How are you going to figure out what's relevant? And this is also important for real life, right? If you've got a dog, and we're going to try to do this in your home and tell you if your dog has arthritis, you're not going to take great footage. It's not always going to be facing the right way, and so on. So we did a bunch of work that I would like to think is fairly innovative on how to handle this problem of figuring out what frames to look at and figuring out what's relevant to the diagnosis. So I'm going to show you the results in a second, but before I can, I got to set a little terminology, otherwise I think it won't make much sense. So 2 numbers we're going to talk about. One is recall and one is precision. So recall is, of the set of all dogs, right? So this little diagram here is squares like all the dogs in the universe. And this half has arthritis, and this half does not. And the circle is what our algorithm identifies. So everything in the circle, our algorithm said, these dogs have arthritis. So recall is the fraction of dogs that have arthritis, everything in this rectangle that we identified, right? So you want to be at 100% recall. You want to identify every dog that has arthritis correctly. Not going to be able to do that. Precision is, of the set that we didn't identify, so of everything in this circle, what fraction will we write about? And as I'll explain in a second, there's a trade-off between them. Let me pause there. Do those 2 terms make sense? Precision or recall?
Would those be the same as sensitivity and specificity?
So recall is exactly the same as sensitivity. Precision is 1 minus specificity.
Okay.
So specificity is true negative rate, and in a ROC curve, false positive rate is 1 minus specificity. Precision's a little different, but it's very related. And for those not in the know, are you in the medical community?
No, I'm just an old guy.
Okay. Machine learning people talk about precision and recall, and medical people talk about sensitivity and specificity. And I don't know, there's historical reasons for it, but I don't know what they are. Okay, so why is there a trade-off? Well, if you tell me you want to get 100% recall, right? Find every dog that has arthritis. That's super easy. All dogs have arthritis. Got 100% recall, I win. Round of applause, we're all done, right? You're like, okay, that's bad. There's tons of false positives. You're telling me lots of dogs have arthritis that don't. I don't want you to make mistakes. What I really want is very high precision. If you tell me a dog has arthritis, it better have arthritis. That's pretty easy too. You just find some ancient, sad old dog who can barely move, and you're like, that one. 100% precision, right? But my recall is really bad. And of course, there's anything in between. So what you do, The model doesn't just say this dog has arthritis or not, it gives you a score. And the higher the score, the more likely it is the dog has arthritis. So you can sort all of those dogs. So the top of the list is the dog that we think is most likely to have arthritis. Second on the list is second most likely to have arthritis. Third on the list is third most likely, and so on, right? If I take the top one, I got a sample size of only one, but I can say what was my precision in recall if I only identified that one dog. Hopefully, recall is going to be very low. Obviously, it's going to be 1 out of whatever the population was, but hopefully my precision is really high. If I take the top 2 of those 2 dogs, what was my precision in recall? If I take the top 3 and so on. And you can kind of cut it off wherever you want. You can learn that, like, all right, my tolerance for false positives is whatever it is, and so I'm only going to count it when my model is this short, or less, right? You get kind of a set of trade-offs. Does that make sense to everyone? Okay. So then, with no further ado, this is a precision recall curve, and this particular one is for a perfect model. So on this axis is recall, right? I didn't find any dogs who have arthritis. I found 100% dogs that have arthritis. As I go this way, typically my precision goes down. I'm identifying more and more dogs, and so I'm going to start to let some through that didn't really happen. And this is precision. And so where you want to be is right there, at 100% precision with 100% recall. That's the perfect model. On the other end of the spectrum, this is the random model. So this is, I have no idea, my model is absolute garbage. You're going to show me a dog, and I'm just going to roll dice and be like, yeah, he's got arthritis, or he doesn't. I'm completely guessing. In that case, whatever the fraction of the dogs is in my data set that have arthritis, that's roughly where my line is going to be. It's going to wiggle around a little, right? But if I pick a dog and I say that one's got arthritis, the probability I'm correct is just whatever the fraction is in the population that has arthritis, right? So between here and here, that's the space for us to be good. Make sense? So these are our results. So this is just on the test set. And so you can see we have 100% precision out to, I'm going to tell you on the next slide, but memory serves at like 38% recall. So that means on this data set at least, although there's lots and lots of ML experiments, and if you know this stuff, we did n-fold cross-validation and so on, so there's reason to believe that this is really believable, even though there's only 44 dogs in the data set. We can identify about 1/3 of the cases of arthritis with 0 false positives. And after that, it starts to fall off. But given the fact that we're missing like 70-80% of the cases, that's still potentially really helpful. And this dotted line is for this test set. That's the random classifier, right? That's the fraction error. Does that make sense? So what did I say? 38? I was wrong. 37. So 37% of dogs we could identify in that data set with 100% precision. And if you know what n-fold cross-validation is, we did 10-fold cross-validation and across lots of experiments. I trained hundreds of models over months. That's pretty consistent. Where somebody's better, sometimes worse, but that seems pretty representative of our performance.
What are the red dots on the graph mean?
You're going to find out on the next one.
Oh.
Thank you for this question. So I had mentioned that we had 4 vets who watched the same videos, but did not get to see the medical records and did not get to see the x-rays. So each dot is how one of those vets did. So one of those vets watching these videos got 72% precision with only 30% recall. So we're above them, right? We're clearly better at this game than this particular vet. This vet we're about tied with. This vet is a little better than us, but it's arguable that when you're that far out on the curve where you have your precision's that low, that's maybe not so useful. And this vet, interestingly, I'm not going to name names, but he is a well-known osteoarthritis specialist, and he apparently just thinks all dogs have arthritis. He is worse than I am. But the take-home here is we are roughly as accurate or maybe more accurate than veterinarians at assessing osteoarthritis from videos. Not to say we're as good as a veterinarian who gets to actually manipulate the dog and take x-rays and so on, but if you were to, and people do this all the time, by the way, which we're going to see in a second, everyone goes into the vet with a video on their phone and like, look, Fido walks funny, what's up with that? The chance that your vet can spot that from the video is about the same as the chance that our algorithm can spot it. And if you really care about the high precision, right, if you want to build some kind of early warning system, then this would be great, right? There's lots of ways you can imagine deploying this. We've talked about lots of stuff, but like one idea, imagine every Ring doorbell comes with RML in it, and every time you take your dog out for a walk, we look at the video and we just assess. And if we're really confident your dog has arthritis, you get an alert. It's like, hey, you should go to the vet. you don't want a false alarm a lot, you lose credibility really quickly. And with this kind of precision, there's at least an indication that we could probably build something like that. That would be really useful. Make sense? Yes.
What causes the sawtooth? I'm trying to figure out if I can deduce your sample size from the like height of the drops or not.
Yeah, you could. So remember, we sorted all the cases by our confidence, right? So this was like, I don't know, the 30 dogs we're most confident about, we did great. Then when we got to 31, we missed one dog, right? So we dropped. When we got to 32, we got that one right. So our precision goes up a little bit, because that makes sense? So you get the little sizes. And yes, you absolutely could reverse engineer the size of the data. Someone else had a question?
Yeah, what is the cost to process one set of video? You mentioned like throw it on the Ring door camera. If I'm gonna subscribe to this service, what is your cost of processing this every time you walk out the door?
So,
If you're allowed to talk about that.
yeah. I mean, I haven't computed like the actual dollar cost, but it's reasonably low. So, to process like a 10-minute video currently takes about 20 minutes,
Okay.
but that's not all expensive GPU time. So we're 2 to 1. Most of that time is like just decoding video, extracting frames and things like, and then there's some heuristics about which frames we're going to consider and all that kind of stuff. That's like 90% of the time. And then you hit the GPU for a little bit. And the reason we're 2 to 1 now is all this stuff is written in Python because it's machine learning and you just kind of have to. And so it's single threaded, so like we pull a frame out, we then do some stuff on it, we then resize it. I am in the process of rewriting this in Go and then using PyTorch on the back end in Go. We can then parallelize that, so we should get to a little less than 1 to 1. And since the bulk of the processing is on the video extraction and not on the expensive model stuff, it actually doesn't help us all that much because you need a big GPU just because you need a ton of GPU memory. But I'm a ballpark guesstimate if you were doing this at scale, right? You're paying for resources. So if you're paying for a GPU and not using it, you're not amortizing the cost. But let's assume we got enough customers that whatever resources we have are always busy. I'm going to guess a penny or two per video, something like that. And you can do things to make it much cheaper, right? So if we just get a video, we can run some very cheap models and be like, is there a dog in here? I'm going to ignore that, and that's tiny fractions of the day.
You potentially even push that to client side?
Yeah, that part. Well, you're probably not in a Ring doorbell, but in other things.
There's smart home stuff in there
Yeah.
somewhere.
Any other questions? Yeah.
Do you have a sense of how that curve might get better if you have a bigger training set?
A little bit, and I'll show some slides later on that give some hints that there's a lot of room for improvement here. But, I mean, perfectly transparently, I don't know. Given what we've seen in the data, like I said, I'll show you another couple data point or two. There is reason to be pretty optimistic, but one of the things I've learned after 20 years of machine learning is don't trust your intuition too much. It's always very surprising. So we'll have to see. Yeah.
How adaptable could this be, like if you added another stream of data, like accelerometer data from a dog?
I would imagine that would help,
Yeah.
but I haven't tried it. I think it's hard to think. So the barrier to entry, I think, is already pretty high. So one of the really big challenges with this is if you don't think, like let's say we put an app out on the App Store that was like, hey, take a video of your dog and we'll tell you if it has arthritis. This is pure hypothesis. I don't know this. But if you don't think your dog has arthritis, you're not going to download the app. If you do think your dog has arthritis, you're going to go to the vet. So my hypothesis is that's not an enormously helpful technology. So I think we have to find, and I'll tell you what our deployment plans are and what we're building, but I think you have to find a more kind of frictionless way to do that. And a couple slides from now we'll talk about those.
We should chat at the end.
Oh, okay, yeah, you got ideas?
I worked for a company that was a GPS dog color, so.
Oh, was it whistle?
No, fly.
Okay, yep. Cool. Yes, that would be, yes. And Whistle anyway already has some of this from the collars, but it's not super active. For those who don't know, a Whistle collar, it's like a Fitbit for your dog. So you put this collar on, you get a phone app, and it's like, your dog ran 2 miles today, and whatever. Okay, so really interesting. Maybe we're only finding the really obvious cases, right? You did really well, but we talked about we ranked the dogs. So maybe the dogs we identified are the ones that like any idiot could tell that dog's got arthritis, it can barely move. So as part of this assessment, there's a questionnaire the owners fill out. It's called the load questionnaire. It's 20 questions. No, it's not that. 15 questions, something like that. And it asks, like, does your dog seem like he's getting lazier than he used to? Is he running less? And do you think your dog, might have arthritis? So we have data not only about what dogs did, but whether their owners thought they did. So we're going to take our test data set. We're going to remove any dogs that had arthritis and their owners knew it, and keep everything else, right? So that's all the dogs that don't have arthritis, and the dogs who did have arthritis but their owners were unaware, and do exactly the same thing. So you notice the random line drops down, right? Because there's a smaller fraction of dogs in the data set who actually have arthritis. And we're still doing pretty good, right? We are identifying 28%, so almost 30% of the cases owners would have missed. So if we were to build this into some kind of early warning system, there's potential here that 30% of people who have a dog that's in pain, who are doing nothing about it, we could help. So I mentioned this at the beginning, the trial was always specific because our pharma partner, that's the drugs they have to sell. But there's no particular reason to think our algorithm is all always specific. Right? We're really noticing gait abnormalities, and there's lots of other things that could be wrong. Hip dysplasia, pinched nerves, injury, whatever. I think it's both good news and bad news. The good news is that's a larger pool of dogs with more problems that we could potentially identify and help. But I think it makes it much harder to say this is what's wrong. At this stage, my goal anyway, is not to get that specific. It's just to let people know you're missing something, you should go see your vet, and we'll take it from there.
You could pretty easily build in though, like, this is a gradual curve, downward curve of mobility over 6 months to a year versus this is a flat line and a sudden drop off.
Yeah, we have not done, we don't have any data sets of dogs over time. I'll talk in a little bit about the app, our ability to get more data, and that should provide that for us. I think, so it is unknown, right, if we didn't catch the dog's OA the first time, would we catch it the second? Would we catch it the third? Like maybe it jitters, maybe we catch it and miss it and catch it. Or maybe we're very consistent. Any dog who has the kind of abnormality that we can detect, we can always detect. So I don't know if we could do that, but I'm hoping. Somebody, I think you would ask, is there a reason to think if we got more data, we could do better? And this is one good reason, right? So the training data, lots of dogs had arthritis, but not all on the same limb. And you got to believe a dog with arthritis in its elbow moves different than a dog with arthritis in its hind knee, right? So this was the distribution in the training data of the affected joint. And if you match that up to our performance on the dogs by affected joint, it's a pretty good match. It's not perfect, but not surprisingly, there's very few hocks and very few carpus in the data set, and we're really, really bad at those. There's a lot of stifle, we do pretty well on that. Surprisingly, we're great at elbow. Elbows, I don't know why, we just kick ass at elbows. But there's reason to think if we got more data, all the carpus and hock cases that we're missing now, we would then get. And please don't ask me what a carpus and hock is, I always forget. But if you really want to know, at the very last slide, I have a diagram of dog things. So, at this stage, our challenge is a couple things. Well, one is we're a very small startup, so how do we stay alive? But the second is, how do we start moving this into something kind of production-like? And related, how do we start getting data? Right? How do we get more data? Because our data set's very small. So we'd like to get to a place where we're working with partners who are helping us get data all the time, and the algorithm we currently have is actually being used and is useful, and we're getting real feedback, right? So we're identifying cases, those people go to the vet, we find out from the vet where we right or wrong, and then we get just additional data, right? So we thought a whole lot about how do you do this. So I mentioned this before, background, owners share videos with their vet all the time. Just quick show of hands, how many people here own a dog? How many people have brought a video of their dog to their vet and showed it to them on their phone? Yeah, that's about right. You're worried about your dog, right? As you know, it's very hard to get your dog to act normally in the office, so you capture video, you go to the vet and you're like, look at this. A couple problems with that. One is, it's a tiny little screen. Second is that it never gets attached to the patient's chart. So when you come back in 6 months and you're like, I think he's worse now, they don't have the original video to compare to. They don't have an easy way, if you're like, should I come in? They don't have an easy way to be like, send me a video. They often send texts, but if you've ever seen a video in text, it's downsized, it's tiny, it's grainy. So vets would really like a way to get videos from owners, organize them, store them, be able to manage them over time, and make it really easy for owners to give them good videos too, not just like a video like they're on a walk and the camera's wobbling all over. So we have started, and I'm going to do a demo, and please go easy on me. The demo here is 2 people, about 3 weeks of work. So this is early stage demo. If I click on the wrong thing, shit's going to crash. But it works, and we've actually got a couple of vets using it as like alpha minus testers. So here's the idea. There's a couple ways this could be used. Like a first cut is, you've got an appointment on the books for your vet. We can automate this. We're working on integrating with what are called PIM systems, which I think is patient information management, or pet, anyway. So we can integrate that and say, like, here's all the dogs who have an appointment coming up in 3 days. Here's the contact info for the pet, for the owner. We're going to send them a text or an email that says, hey, you've got an appointment coming up in 3 days. As you know, it's hard to assess your dog. It'd be great if you could shoot a video before you come in. They would shoot a video, upload it, our ML would run on it, and then when the owner comes in, the vet sits down, brings up our little dashboard. They can watch the video, but they can also, there'll be like some kind of icon that's like, we're worried about this one, make sure we look at this. You could also imagine an owner's concerned and they think their dog has arthritis and the vet can't assess it. So they schedule, like every month, they're going to send this email. It's like, hey, please send us another video, right? And we'll keep doing that. And when they come in the morning, they get an email with some alerts. Yeah, we saw a new video of Fido today and it doesn't look good. You should take a look at that and maybe schedule it. This is our initial hypothesis, and like I said, we have built some of this, and I'm going to do a crappy demo of it in a moment. In fact, I'm going to do a crappy demo of it now. I don't know how to do this with the microphone. I think this part's going to be unmiked. You guys can hear me okay, yeah? Okay.
Yeah, those questions.
Yeah, sorry. Okay, so, reminder, 2 people, 3 weeks. So this is our vet portal, right? Oh, no, yeah, there we go. So this is our vet portal. It shows all these different, what we're calling checkup requests. So this is, you sent a request to a pet owner and said, hey, I'd like to see a video of your dog. Hopefully this will be automated. Hopefully it'll be integrated with the patient information management system. But for now, it's just this. And the status, it's got a check mark. It means the owner actually took the video you requested and uploaded it. If it's just a circle, it means the video hasn't come in yet. So to create a checkup request, this is a quick one, and I'm going to say Courtenay, who's that silly little dog you guys saw at the beginning, and it gives me a link. So at this point, we're not integrated with stuff, but you can copy and paste that and text it to them or send it an email. Most patient information management systems have like a whole contact thing where communications with the owners get attached to the chart and stuff. So presumably you've got another tab open with your PIM system, and you just copy paste that link to an email. Please send me a video. Okay. So I'm going to send that video to my phone right now. And my phone is currently being shared with you. I joined a Google Meet meeting with myself so you can see my phone. And let me open Chrome here. And I'm using KDE Connect, so I can just paste that link. So here's the checkup request. Okay. And it says, your vet requested a video of your dog. So I click Get Started. And there's this video, I won't bother playing all of it for you, but it gives them instructions on how to take a good video. This is what we want you to do. Please, if you don't have a tripod, you can use a soup can, and please walk your dog around like this, and so on. And it goes on for a little bit, but you get the idea, it gives some instructions. We're talking a lot about how to make this better, right? We've talked about having like a decision tree-like thing, like, do you have stairs? Great, walk your dog up and down the stairs. Can your dog sit on command? Great, please ask your dog to sit. And upload multiple videos, but this is our straw man for now. And now I can either take a video, or if I already have one, I can do this, and my camera roll shows up, and you can see most of my phone is videos of my dog. But let's say I'm going to take a video, so I'm going to tap here to take a video, and the native camera app opens up, and everybody wave. Okay, oh, hang on, okay, there we go. So I take a video. And I'm done taking my video, and so I click that, and it immediately starts to upload.
Can it tell who has arthritis?
And then,
Let's go find the dog among us.
and if we go back here, you can see there's a check mark now that video is complete. if you click on it, there's the video, and there's all you guys. $0. Yeah, $0. And as you can tell, we don't have the ML plugged in yet. That's the next step. That's the rewrite the thing and go so it's fast and reasonable and all that kind of stuff. But at this point, we've got the video, and so kicking off a job to run the ML over it is technically not hard. It's a bunch of work, but it's not like technically challenging. So I think I'm almost done here. Thanks everyone for their patience. So last little bit. So where we're going is there's a couple more pharmaceutical companies who are interested in what we're doing. We've been lucky enough to get some really heavy hitters, like I mentioned, Duncan LaSalle on our board. His opinion carries a lot of weight, and pharmaceutical companies are realizing this is coming. Most of them that we've talked to have had their own internal efforts to do this for years. And the fact that we did this in a few months, they're like super excited, and they realize we may be a different team than they were able to assemble. So we are in kind of late stage talks with the C-suite of a couple different pharma companies about spinning up bigger trials. Unclear exactly what that would look like, but I mean, I think we'll know in weeks. But it would be something like recruit a bunch of vets to use that app I just showed you, so they're actually getting footage in home. Then the vet is going to do their assessment, so that'll be our ground truth. We're going to get those videos. We'll run the ML on it anyway, so we can see how accurate we are, but then we'll also use that as data. We've already got about 5 clinics spun up, and so we're generating data already at like 4 times the rate that we were able to in that trial without all that expense. And then eventually other health conditions. Weight, we've actually already done. We have a dog fat shaming device. And neurological, skin conditions, all kinds of stuff we'd like to get into eventually.
Just a quick note, I think there's a typo that says trails instead of trials.
That was all through the presentation.
Oh, is that right?
Oh, because it was dogs.
No, that's because I can't spell. There's I have a couple like really consistent spelling errors.
No, just like if you're using this for a presentation for I don't know,
Yeah.
or whatever, might as well get it right there.
Yep. So that's it. Unless anyone's got questions. Oh, by the way, here's your dog now. It's small. Yeah.
Are you working on any patents or like proprietary technology or whatever, or is it all just like trade secrets?
So we are working with patent attorneys. We already have a few patents. I personally, I kind of hate this space. The intellectual property space makes me pretty uncomfortable, I gotta admit.
Necessary.
Yeah, and the patent system's kind of weird. So patents don't offer you a whole lot of protection in reality. Like if a big company decides they're gonna infringe on your patent and you don't have a ton of lawyer money, it doesn't really matter. So there's this funny thing where if your work is really valuable, maybe it's a trade secret, and if it's only a little bit valuable, you maybe patent it, and we're kind of going round and round with our attorneys. I don't know what we're going to do. But we already have the classic, very general, like a system to process videos of dogs on a computer, if we have one of those. Yeah.
One of the stats on one of the first slides talked about, I think it was like 12% of owners get treatment. I think worse to that effect, and I didn't know if that was 12% that know the dog needs treatment, and then like there's 88-ish% that kind of go, well, my dog needs treatment, but I'm not, or if it's just if they knew or didn't know, basically.
So that was very specific to a single study. So that was a study where Duncan recruited, I can't remember, several hundred dogs at random, under the age of 4, over the age of 8 months. Of the dogs in that study who were identified as having arthritis, only 12% getting treatment. Now you got to imagine they're younger dogs, so the diagnosis rate is lower. There's other non-published work that the pharma companies we work with have done that show the under-treatment rate is very high, but I've heard wild swings there. I've never heard anything like that's like 50% are being treated, but I've heard anything from like 20% to 70%. So it's
Okay, thanks.
Yep. Yeah.
Are people trying this with humans?
Yes. And I don't know a whole lot about that work. One of the nice things about working with dogs is there's like no HIPAA regulations. You don't have to go through the FDA. It's a much, much easier path. Although it is interesting working with pharma companies. They're so used to working with human data. They keep being like, have you triple encrypted all the data? And I'm like, dude, it's a dog.
Those lawyers are not coming out.
I guess people can tell you they have joint pain as well.
Yes, yes. So it's less valuable in that space. But there are lots of things like for athletes. There's all these apps that'll tell you like you're not running right if you're a jogger, and that's why you can cut dogs down the line. Things like that. Any other questions?
Cats next.
Maybe actually, because cats are even harder than dogs at the vet. Like they don't even come out of the cat carrier when you get to the vet.
Yeah.
So yes, that is on the roadmap. And actually, there is a drug company called Zoetis who already has a tool called Cat IQ that's supposed to do this. I played with it some recently, and it's not very good. It's like I think it was 3 hours from video upload to getting an answer, and the answer was very vague, and I'm pretty sure there's a man behind the curtain. Yeah, but yeah, there's definitely interest in that.
Can you tell us a little about your tech stack? Are you on the Azure cloud or the Amazon cloud or Google?
We're on Google Cloud, Kubernetes. The Google now very recently has added this very nice, what do they call it? Kubernetes Autopilot. So you spin it up and you have 0 nodes running. And when you submit a job, you say what resources you need. And if there aren't sufficient resources in your node pool, they will spin up exactly the number of nodes you need for that, very much like AWS Lambda or something. But it's all Kubernetes, which is nice. They can even do smart things like if you put your resource requirements are you need a GPU, they'll spin up a GPU instance for you. It's really kind of pretty. Database is CockroachDB, which I can talk about some other time, but it is it's open source cloud spanner, if that means anything to anyone. Very horizontally scalable database like NoSQL databases, but it's actually fully SQL and ASCII. Any question?
Yeah.
All the backend servers are Go, front end is TypeScript React.
Are you using any open source models? Did you build your own proprietary model, or are you just using someone else's?
So it's definitely not someone else's. There's a lot of new stuff in that model. But there are, like I said, there are some components that are pre-trained. And then you take those outputs and a bunch of other stuff happens.
And does things like Gemini that just came out excite you because you can now just send it a video and ask it, does this thing have arthritis?
I don't think that would work, but you could try it. Yeah.
Okay.
Yeah. Foundation models are cool, but they, I don't think any of them are nearly that specific. But yeah, it'd be interesting to try. Cool. Yeah, I should cede the floor way over time. Thank you. Thank you.